Question 5, we have another constructed triangle, but they're all these right angle triangles. If we take 13 squared, 12 squared, and 5 squared, you should identify this already through your working trig as a Pythagorean triple. These two add up to 169. So that's where we have a 12, a 5, and a 13 as the diagonal. Gives us one of these right angle triangles we see a lot. And if we label it properly now, the diagonal is AC. AC, BC is 12, and AB is 5. And the converse of Pythagoras' theorem I'm going to put up now for you to learn. So this is it. Pause the video, read it off, and I'll test you in class tomorrow. We're asked to show that the triangle is right angled at B, so that the right angle is here. So we would have to show that 5 squared plus 12 squared equals 13 squared. 169 equals 169. So you can say therefore right angled at B. We're asked to write the cos of ACB. ACB, the letter in the middle. Here it is here. So we're asked to write the cos of the angle C is equal to A over H. So H is 13. We don't want the opposite, which is 5. A is 12. So 12 over 13. And hence find the angle to the nearest degree. So the inverse cos of 12 over 13 gives the angle size, which is 22.619. Correct to the nearest degree, 23 degrees. Question 7 goes into a homeowner wanting to replace 3 identical steps leading to her front door, and each step is 10 centimeters high. And we can see the base here will be 35 by 3, which is 105. We have 3 35s going this way. And then we have 10s going this way. And then this will be the 3 10s, which will be 30. And they're all in cm, so add to the diagram if you can. So we've added enough information to the diagram. That's 30 and this is 105. So the length of the ramp, based on your knowledge of Pythagoras, the square root of 30 squared plus 105 squared, and we're asked correct to 1 decimal place. 109.2 correct 1 decimal place. And part B, we have 2 different triangles. So we have this one on the left where we have H and 30 degrees, and then we have one on the right which we also have H in. We have 60 degrees, and we have this side X. So we'll take each individual triangle out as we need. We want to write H in terms of X, so that's the triangle on the right. We have X, we have 60, and we have H, and we label our triangle. We can see that we're dealing with the opposite side and the adjacent side. So we're going to say the tan of 60 is equal to O over A, which is H over X. So X tan 60, which is root 3, is equal to H. So root 3x, not root x, root 3x, or x root 3 equals H. So now we have to use the other triangle to get x in terms of H as well. There's a root 3 went missing. So we take the triangle on the left now. And the information down the bottom is that the whole length is 24. So we have to take away x to get this one. So this is 24 minus x. We also have h again. We have 30 degrees. You can see it's going to be tan, opposite, and adjacent. The tan of 30 degrees is equal to O over A, which is h over 24 minus x. So 24 minus x by the tan of 30 is equal to h. And tan 30 is 1 over root 3. So 24 minus x by 1 over root 3, which just moves the root 3 onto the bottom, is equal to h. And now we have two equivalents. We have h in two different formats. We have x root 3 is equal to 24 minus x over root 3. This is what my two h's are equal to. Imagine that's just the root 3 on the bottom, and 24 minus x times 1. So if we cross multiply, and now see it's root 3. Just be careful. So x root 3 is going to be 3x. This one by this one. That's going to be equal to 24 minus x. So bringing x to the left, we get 3x plus x is 24. So x is equal to 6. And we're asked, you've done all the work, so just read the question carefully. Find the height of the two poles. So h is equal to x by root 3. H is equal to 6 root 3. And it asks for it doesn't ask for a corrected two decimals, so we'll leave it as 6 root 3. And that will be in meters.